Alright, welcome back to the Green Ninja Climate Science series. In this video we're going to be talking about the question, hasn't climate changed before? So you hear this question come up sometimes when kind of the insinuation is that if climate has changed before, then we don't know that current climate change is being caused by humans. But as we'll see in this video, scientists actually use past climate changes to figure out how the climate system works and to figure out, how much climate change we would expect for, say, for doubling CO2 concentrations, which we're expected to do by the middle of the century. So first of all, just to answer the question emphatically, yes, climate has changed before. So the Earth is about 4.5 billion years old, and over its lifetime, climate has changed many times. And climate change has been the rule over longer time periods. But the point is that scientists can use those climate changes to understand how the climate system works and to better understand what we would expect over the next 100 years as we change the amount of greenhouse gases in the atmosphere. So just to give you a broad idea of how this might work, looking at, say, the past 400 million years, we can see a relationship between a couple variables in this graph. So what we're looking at here is an estimate of the atmospheric CO2 concentration from various lines of geological evidence and from different computer simulation models. And we can see that the amount of CO2 in the atmosphere has gone up and down over time. And then what these blue blocks are showing is, over the same time period, how far south continental glaciers extended. So 90 degrees is the North Pole, and then 0 degrees is the equator. So we're showing that at certain times in the Earth's history, we had glaciers down close to 30 degrees of latitude, and then in other times we had no glaciers at all. And so you can see a relationship between these two variables, that when CO2 was low over the course of this 400 million years, glaciers tended to extend pretty far south. And when CO2 was high, there tended to be no glaciers on the surface of the continent. So what this means is that we can look at this relationship and try to tease out how much temperature change is accounted for by different levels in greenhouse gases. So we can look at different time scales, so zooming into this last kind of sliver of the graph in more recent time periods, we can look at how the climate has changed over the past 500,000 years in this case. And what we see is that there have been cyclical changes in climate. The temperature of the Earth has swung by about 4 degrees Celsius up and down in these 100,000 year cycles, which their name is Milankovitch cycles. And we don't really have time, it's kind of beyond the scope of these videos, to go into the mechanisms behind Milankovitch cycles. But it has to do very broadly with the Earth's orbit around the Sun and how much solar radiation hits different parts of the Earth at different times of the year. But one point that's worth making here is that when scientists have studied these oscillations in climate, they've found that greenhouse gases play a very important role in how big a temperature changes we actually saw over this 500,000 year period. So changes in greenhouse gases didn't directly cause this 100,000 year cycle in climate. As I said, changes in the orbit of the Earth around the Sun did. But greenhouse gases very much enhanced how big of temperature changes we saw during these cycles. So scientists have used all sorts of different means to try to extract how big the effect from greenhouse gases has been in these Milankovitch cycles. But again, the point here is that we're using Earth's climate history, we're using climate changes of the past to get an idea of how important greenhouse gases are and how important, in particular, CO2 is. Looking at a different time scale, we can look at just over the past 1,200 years about. So we're showing the years prior to 800 all the way up to the year 2000 here, where this black line is the instrumental meteorological temperature data set that I've been showing in other graphs, and then back further the picture is fuzzier because we're not measuring temperature directly, we're measuring it from proxies of temperature, things that change with temperature like tree ring width and various other chemical signatures in ice cores and things like that. So anyway, the picture is fuzzier as you go back, but we can study these little wiggles in temperature change, and we can look at how solar radiation changed over that time period, how volcanic eruptions changed over that time period, and again use those to quantify how big of a deal these things are when it comes to changes in temperature. So scientists, a ton of their understanding of the climate system comes from the fact that climate has changed before, and we have these data sets to look at to figure out how big an influence the sun is, and how big an influence volcanic eruptions are, and how big of influence greenhouse gas levels are. So the fact that climate has changed before certainly doesn't mean that humans can't be causing the current climate change. I mean, by that logic, you could say that because people sometimes die of natural causes, that means that murder doesn't exist or something, right? Just because people die of natural causes, it doesn't mean that someone can't also be murdered. And just because the climate has changed before doesn't mean that that humans can't be causing the current climate change. And in fact, when we look at how climate has changed before, we see very strong evidence that greenhouse gases actually make a huge difference in why the climate has changed in the past. So has the climate changed before? Yes. But studying it allows us to better understand how the climate is changing currently and what to expect in the next, say, 100 years.